Today we're going to talk about factoring quadratics, and this is useful for going from standard form of a quadratic to intercept form and allowing us to solve some other quadratics. Remember, factors are two numbers that multiply to a given number, like 4 and 2 are factors of 8 because 4 times 2 is equal to 8. And the greatest common factor is the biggest factor that two or more numbers share. So let's start off by finding the greatest common factor. And you may look at 24 and 36 and they think, well, 6 is a big factor of both of those, but is there a bigger one? And actually, 12 is the biggest factor that both of them share. 12 is the greatest common factor because 12 times 2 is 24, and 12 times 3 is 36. So 12 is your GCF. Right. Now negative 72 and 8. Well, the biggest common factor here, or the greatest common factor here would be 8, because 8 times 1 is equal to 8, and 8 times negative 9 is equal to negative 72. So you can use you can have a greatest common factor between a positive and a negative number. Now let's look at letter C over here, where we have negative 44x, 24x, and negative 8x squared. So they all have an x in common, so our greatest common factor is going to have an x in it. And then we have to look at the numbers, negative 44, positive 24, and 8. And the greatest common factor between those numbers would be 4. So our greatest common factor for all four of them, or sorry, all three of them, is 4x. And you can do 4x times negative 11 gives you negative 44x. 4x times 8 gives you 24x. And 4x times negative 2x gives you negative 8x squared. So we can have letters as part of our GCF. We can also use the GCF to simplify expressions or equations to make them easier to work with. So in A, if we look at what all these have in common, they all have at least a 2 in common. So what we can do is we can factor out a 2, and then what's left on the inside would be 2x squared minus 9x plus 24. So when you're factoring like this, you can think about dividing. What would be left over? If I took 2 and divided it by 4x squared, I would get 2x squared. If I took 2 and divided it by negative 18x, I would get negative 9x. If I took 2 and divided it by 48, you would get 24. So that's how you can kind of figure out what you would have left to deal with on the inside of our parentheses. And you can always distribute this back and see if you get the original answer. And I'm not going to do it on this one. I'll do it on letter B so that doesn't get all messy over here. So I look at 6x squared minus 36x minus 72. That can be confusing to deal with, but they all have all these values here, all these terms have a 6 in common. So I can factor out a 6, and I'm left with 6x squared divided by 6 is just x squared. Negative 36x divided by 6 is negative 6x. And negative 72 divided by 6 is going to be negative 12. And I'll show you what I mean by checking your answer. If you distribute this back in, 6 times x squared is 6x squared. 6 times negative 6x is negative 36x, and 6 times negative 12 is negative 72. So you get the same thing that we started with. So I know that I factored this correctly. And then the last one over here is 2x to the third minus 4x squared plus 16x. So I notice they all have an x in common, and I can divide each of these numbers by 2. So I'm going to have 2x, and then on the inside I'll have x squared, because 2x to the third divided by 2x will just be x squared. Negative 4x squared divided by 2x will be negative 2x. And 16x divided by 2x will be positive 8. And that is my factored answer. All right, on to the next page. I want you to try to factor these taking the GCF out. So pause the video and see if you can factor these by just taking the GCF, the greatest common factor, out. And then once you're done, unpause it and see if we got the same answer. All right, so this is what I got. And again, you can always double check by multiplying this back and see if you get the original answer. Now, like I said at the beginning, the reason why we want to know how to factor is because we can go from standard form to intercept form of the quadratic and then find our x-intercepts. So let's look at this quadratic factorial expression x squared plus 5x plus 4 to find the zeros of the function. So then over here, what we don't, there's no greatest common factor here. Like they don't have an x in common, they don't have anything else in common. So we're going to use a factoring technique that uses what I call magic numbers. So what we want to do is we want to find two numbers. We want to find two numbers that multiply to our c value but add to our b value. So in standard form, remember the number in front of x squared is a, the number in front of x is b, and the number with no x is c. So c is 4 and b is 5. So what are two numbers that multiply to 4 but add to 5? That is the numbers 4 and 1. And we can check that. 4 times 1 is 4, and 4 plus 1 is 5. So we're going to rewrite this expression using our magic numbers. So it's going to be x plus 4 and x plus 1. So now that we have it in intercept form, we can find the zeros easily by setting each factor equal to 0. So x plus 4 equals 0, and x plus 1 equals 0. Well, subtract 4, get x equals negative 4. Subtract 1 from both sides of the second equation, x equals negative 1. So the two zeros are the two x-intercepts, and the two zeros are right here, negative 4 and negative 1. Now this trick will only work if a is equal to 1. That makes factoring pretty easy. So we're going to now combine these two things down here, where we're going to try to find our magic numbers and factor it, and then find our zeros. Always look for a GCF first, because that will make life easier. In letter A, I don't see any GCF. There's no number that 1, negative 7, and positive 12 have in common. So now I need to find my magic numbers. B is negative 7, and C is positive 12. So two numbers that multiply to positive 12 but add to negative 7. Well, negative 3 plus negative 4 is negative 7, and negative 3 times negative 4 is positive 12. So my two magic numbers are negative 3 and negative 4. So we're going to rewrite this as x minus 3 times x minus 4. And then our zeros are the opposite of what you'd see. So x equals 3 and x equals 4. So not too difficult when a is 1. Here a is not 1 in letter B. And normally it might be a little bit more difficult, and we'll talk about that later when a is not 1. But all of these numbers have a 2 in common. So we can factor out a 2. Okay, so then we just have to factor this one thing on the inside. So we have our b value of 3 and our c value of negative 4. So two numbers that multiply to negative 4 but add to positive 3. Well, 4 plus negative 1 is 3. 4 times negative 1 is negative 4. So our two magic numbers are positive 4 and negative 1. So then we will have x plus 4. There's x minus 1. And then the opposite of that would be negative 4. And then for this one right here, x would equal positive 1. So don't think that if a is not 1 that you automatically have to do something else. See if you can factor out a GCF first. Now letter C over here, you have x squared minus 144. Well, there's no x to the first power. There's no b term. That's okay. If there's no b term, that means b is equal to 0. So b is equal to 0. C is equal to negative 144. So two numbers that add to 0 but multiply to negative 144. So that is going to be 12 and negative 12, because 12 plus negative 12 is 0, and 12 times negative 12 is negative 144. So our two magic numbers are 12 and negative 12. So x minus 12 and x plus 12. We call this a difference of squares, and we're going to talk about that in a second after we get the answers down. So x equals 12 and x equals negative 12. So the reason why, let's write that down. This is a difference of squares. And the reason we call it that is because we have in the original problem x squared, which is something squared, and that something is x. So we have x squared, and then right here we have 144, and they have a subtraction sign between them, or another word for subtraction we sometimes use is difference. 144 is 12 squared. It's a 144 is a perfect square because you can take the square root and get a whole number. So we have x squared, one thing being squared, x squared, minus another thing squared, which in this case is 12, because 12 times 12 is 144. And you see your answer down here, we have x minus 12 and x plus 12. So then the square root of 144 is 12. So this is a shortcut you can use if you recognize this a difference of squares, but if you don't, it's okay. Look, we did it without using the difference of squares. So I hope that this was a good introductory video on factoring. You guys did do this a little bit in Algebra 1, and I just wanted to refresh our memories a little bit, and we're going to take it further in the next couple days. So thanks for watching the video. Make sure you hit the like button and subscribe.